name is Professor Aren
And I'm Nestor Raphael Carbonell. Today, we will be addressing Chapter 3, Parallel and Perpendicular Lines.
Let us begin! The main points of this lesson are angle relationships between two lines in a transversal, the distance, point slope, and slope-intercept formulas as well.
Now before we dive into angle relationships, we need to discuss how these angles are made. These 8 angles are created because of the transversal. A transversal is a line that intersects 2 or more other lines. In doing so, it creates these angle relationships.
These angle relationships include alternate interior angles or AIA, alternate exterior angles or AEA, consecutive interior angles or CIA, and corresponding angles.
In this here image, we can extract a lot of data about these angles. The pairs of alternate exterior angles are angles 1 and 8 and angles 2 and 7. The pairs of alternate interior angles are angles 6 and 3 and angles 4 and 5. One way to remember these is that alternate means opposite sides of the transversal, interior means inside, and exterior means outside. So if they're asking for alternate exterior angles, you will look for angles outside the middle section that are on opposite sides of the transversal.
The pairs of consecutive interior angles are angles 4 and 6 and angles 3 and 5. The pairs of corresponding angles are angles 6 and 2, angles 8 and 4, angles 5 and 1, and angles 7 and 3.
Now the importance of these angles is fairly simple. If the two lines being intersected by the transversal are parallel, then all pairs of alternate exterior angles are congruent, all pairs of alternate interior angles are congruent, and all pairs of corresponding angles are congruent.
The catch here is that not all consecutive interior angles are not congruent, but are in fact supplementary, meaning when we combine the two consecutive interior angles in any given consecutive interior angle pair, we are left with those angles equaling 180 degrees.
Aren, let me take this next lesson. The second topic we will be covering is the distance formula. And although it may seem overwhelming and difficult, it proves very useful in many linear equations. The usefulness of the distance formula is to figure out the distance between 2 points. The distance formula is d equals the square root of y2 minus y1 in parentheses squared plus x2 minus x1 in parentheses squared. In this equation, d stands for distance, y2 stands for the y-coordinate of the second point, y1 stands for the y-coordinate of the first point, x2 stands for the x-coordinate of the second point, and x1 stands for the x-coordinate of the first point. Let's look over an example. In this equation, our 2 points are -2, 1, and 1, 5. Now, let's plug in our points. The y2 in this case is 5 because it is the y-coordinate in the second point. The y1 is 1 because it is the y-coordinate in the first point. The x2 is 1 because it is the x-coordinate in the second point, and the x1 is -2 because it is the x-coordinate in the first point. After plugging everything in, we will follow the order of operations, or PEMDAS. First, we do what is inside the parentheses. Next, we go to exponents. We add before we square root our total, and we get root 25, which equals 5. So the distance between points -2, 1, and 1, and 5 is 5.
Hey Rafa, why don't you join me in for this third topic?
I would love to. Now the third topic we are going to address are the point slope and slope intercept formulas.
Point slope formula is very useful for finding the equation of a straight line, while slope intercept formula is the equation for that very line.
Fascinating.
You use point slope formula to help you figure out slope intercept formula.
And now the formula for point slope is y minus y1 equals m times x minus x1. Wow! y1 is the y-coordinate of a point, x1 is the x-coordinate of a point, and m is the slope of the line. From there, we would simplify to reach the slope-intercept formula y equals mx plus b, where b resembles the point in which the line goes through the y-axis.
Here's an example, where we're given the slope and a point that the line goes through. The slope is -1 and the coordinate is 3, -2.
Now first, we will plug it into the slope and get y minus -2 equals -1 times x minus 3. Next, we will distribute and simplify to get y plus 2 equals -x plus 3.
Subtract the 2 from both sides and you get y equals -x plus 1. You may notice that this corresponds with the slope-intercept formula y equals mx plus b, and that m is -1 and b is +1. That is the equation of this line and helps us figure out all the points that the line goes through.
Oh, well, thank you, class, for your undivided attention. Professor Aren and I would also like to acknowledge Mr. Frost and thank him for giving us the opportunity to teach you guys today. We really hope you learned something meaningful about Chapter 3 and that we have sparked an interest into the many months left you will have being taught geometry. For now, enjoy this clip of Aren and I furiously dancing to our heart's content.